Even if, though, you have a very, very big sample, the sample can still be unrepresentative because of bias. So sample size isn't sufficient when you don't have a random sample. Is that a question? Oh no, you're just scratching your head. Who's read this example in the study guide? If you haven't read it, have a look at it now. So in 1936, this magazine called Literary Digest ran its own opinion poll trying to predict who would be the winner of the presidential election that was happening that year in the US. And their sample consisted of 2 million people. That's massively bigger than any modern poll. No poll has millions of people in it. They have thousands, maybe 2,000, 3,000, something like that at best. Where did they get their poll from? Well, it was from people who had a subscription to the magazine, and they also randomly selected people from the phone book. So it's a bit of random selection, right? Their results were completely wrong. They predicted that this guy, who I'm sure you've never heard of, Alf Langdon, would win by a significant majority. And in fact, the person that you have heard of, probably Roosevelt, won by a significant majority, by a landslide. So this sample was huge. The problem was it was biased. Why was it biased? What's the problem with this sample? If you haven't read the explanation in the study guide, do you want to have a go? Yeah.
Because they use the people who were subscribers, but also because it was only people who have a telephone?
Both of those, yeah. So the point was, it was people who had a telephone or people who had a subscription to this magazine. Why would that matter, though? Yeah.
Because a magazine, it's either really left or really right. So the people who are subscribed to it would be either like really left.
Oh, I see. So there might be some political bias amongst the subscribers to this particular magazine, as there often are. Right. Something else is important, which is the year. Look at the year. So you're from the US?
No, I'm not.
Oh.
Well, I went to US school.
Oh, okay. So does anyone know what was happening in the US in 1936 and in other places in the world? The Great Depression, right? So do you think, so in the Great Depression, massive unemployment, millions and millions of people unemployment, homeless, living in tents in Central Park, right? Do you think they could afford telephones or subscriptions to literary magazines? No, so of course they weren't in the poll. Right? So that's why it got it dramatically wrong. Charmingly, the magazine published a little apology afterwards. Can you imagine a newspaper or magazine doing that now? They admitted that, oh, we got this terribly wrong. Here's another kind of bias that's very common with polls. So TV shows and websites and so on like to do this kind of thing. So they publish a question and ask people to phone in or text message or click a button on the website to indicate their answer. Here's an example. News International ran an online poll last year asking people if they thought Australia should put its troops out of Afghanistan. 6,000 people, very large sample, right, responded, and 80% of them said yes. Is this poll likely to be representative? Definitely not. It's likely to be extremely unrepresentative. Why? Because it's what's called a self-selected sample. These people are selecting themselves to be in the poll, right, by deciding to text in their answer or click the button on the web page. What that means is that people who have very strong opinions, usually negative opinions, because negative opinions tend to have more of an emotional charge, they're more likely to get into this poll. Right? So you should basically never believe any poll like that as being representative of anything about the general population. In almost all, and you can tell this because, here's a clue, if you look on the web pages of a current affair or newspapers that often do this thing, they'll record the results from these polls, and they're nearly always the same, whatever the question is. It's always 80%, 90%, 75% of people said no, usually, to whatever the question is, right? That's because people who want to say no are much more motivated to take part. What's the problem of self-selection? Or voluntary response poll, as it's sometimes called. Another example of that is SETU, right, where you're asked to evaluate units and teaching, which is a noble aim. However, is it compulsory? No. Is it random? No. Who's in the poll? Who decides to do that? Well, I mean, I take it not... They offer a prize these days, but I don't suspect many of you are highly motivated by that. It's going to tend to be, students are going to do the survey if they either really, really hated the unit and were pissed off by it or something, or people who really, really loved it. If your attitude to the unit was a bit meh, it's okay. Are you going to bother saying that in the set of results? Probably not so much. Here's what I think. Do you like this idea? I bet you don't. What we should do instead is choose... So there are 85 students enrolled in this unit. Choose 30 of you really at random. And you have to do the SETU result poll. You have to do it. You can't pass the unit unless you do. Right? So I make it a requirement for those randomly selected 30. Now then I get a really accurate result, because a truly random sample of 30 is going to be pretty representative. And it's not so bad because you don't all have to do it. Do you like this idea?
No, because it's unfair.
No, because it's unfair. Yeah, okay. Yes, it is a bit unfair to the people who get randomly chosen. See, that's an example of that kind of considerization. Oh dear, a kind of consideration that I said was of a different kind to considerations about consequences when you're considering what we ought to do. I just gave you a normative argument, right? We ought to make SETU compulsory for a random sample of students in the unit, right? Now, suppose I could convince you that that would have all these good consequences and no particularly bad ones. Still, there's this point, it's unfair. Right? A different kind of consideration. Let's go back to this example. Notice 13,000 students were asked, but only 5,000 responded. So we've got what people who do surveys and opinion polls would call a problem of non-response. We've got a high proportion of non-responders. That most of the people that were contacted didn't respond. Now, for all we know, the ones who didn't respond could be quite different in their drinking habits to the 500 who did. Right? Perhaps they're all like really, really heavy drinkers, or mostly heavy drinkers and kind of ashamed to admit it, and that's why they didn't respond to the poll. So that means that the sample of 500 is going to be biased towards moderate drinkers. I mean, we don't know whether that's true, but it's just a possibility. The non-response rate here means there's a potential problem of bias in the sample. And you also talk about availability. Again, this is a very common fact about samples, that they don't consist of individuals who had an equal chance of getting into the sample. Rather, they consist of individuals who are easily available to the people doing the sample. So this is potentially a problem with psychology, cognitive science. Most experiments that are done in psychology and which get published, the subjects in those experiments are students, university students. Why? Because they're available, right, to the people doing research, right? It's a big body of people. I mean, we can do our experiments on them, right? And there are often, in fact, it's a course requirement for some psychology degrees that you do some of these, participate in some experiments. So nearly all of what we know or think we know about cognitive science and psychology comes from samples that consist almost entirely of undergraduate university students. Now, that may or may not make much of a difference. In medical research, this is a kind of different problem, but I'll mention it. Not really problem of availability. When you're doing drug trials of new medications, the samples, both the control and the experimental condition, consist entirely of, does anyone know the answer? Men is the answer. Women are usually excluded from medical research experiments. Why? Because they might be pregnant. And the people doing the research don't want to get, well, it's not just that they don't want to get sued. That's a consideration. They don't want to run the risk of something, you know, the medication having some bad effect and it harming the unborn baby. So that's potentially a serious problem. Right? Pretty much everything we think we know about the safety and effectiveness of medications comes from samples that consist entirely of men. Obviously there are exceptions. But that's not availability. Availability is the case when the individuals in the sample are ones that are easily available to you. This is a common problem in sort of everyday reasoning. If you're asked to estimate, if you're asked the question, how likely is such and such to happen? People tend to try and think of examples and then base their estimate of how likely or how frequent something is on what they can remember about examples. But the problem is the examples that you can remember or easily bring to mind, these are in effect cases that are available to you, easily available to your mind, pop up into your mind. They're going to be potentially biased for all sorts of reasons. Atypical. Because, well, to some extent, extreme cases, emotionally laden cases, are easier to bring to mind. And the media tends to report extreme and emotive cases, but not what's typical. And unusual or emotional events are easier to bring to mind, more vividly remembered. So here's a little example. Suppose you took a book, say a novel, big one, and randomly selected a word from it. What do you think is more likely? That you get a word beginning with the letter K, or a word that has K as the third letter? Just have a think about that for a minute. It's a randomly selected word from a text. Is it more likely to start with K or have K as the third letter? Push. What do you think? Start with K? It's the wrong answer. What do you think? What do you think? Yeah? That's the right answer. The right answer to this question should be, I don't know. Right? But that's not the answer to people. People are seldom at a loss if you ask them a question like this. They'll try and answer. Right? The most popular answer tends to be, in this case, that it begins with K. Can anyone think of a word that has K as the third letter? Cake, yeah. Any more? Say again? Bike. Yeah, okay, we've got two. But notice we've got like a few, and it's quite hard to think of them. Which you can think of loads that begin with K. It's easy to think of words that begin with K. But that's the point, it's just easier to think of them, right? So you mix up, so if you like, the sample of cases that you can think of is biased by availability, because it's just easier to think of ones that begin with K than have K as the third letter. In fact, it's much more likely to have K as the third letter, but it doesn't really matter what the answer is. The point is, you shouldn't really base your estimate on sort of introspection and sort of trying to think of cases, because that's likely to be biased. This is the availability fallacy, as I call it. I'll just give you one more example before we end from a study. In this study, people were asked this question: which do you think kills more people every year in the United States? This was an experiment done in the United States. Tornadoes or lightning, stomach cancer or car accidents, diabetes or murder, floods or strokes. Now, again, what's the right answer to all these questions? Right answer is no idea, unless you really do know some relevant statistics about these things. What do you... Now I've told you about the availability fallacy, what do you think the most common answers were to these questions? What did people think was more likely to kill people? Tornadoes or lightning? Tornadoes. Stomach cancer or car accidents? Car accidents. Diabetes or murder? Murder. Floods or strokes? Okay. Well, most people went for floods, right? Just what you predicted. Why? Because those are the ones that are most often repeated in the media. So when I was talking about arguments based on samples, I said for an argument like that to be a good one, the sample has to be representative of the population. And we started talking about ways a sample can fail to be representative. One way is if the sample size is too small. Smaller samples are more likely to be unrepresentative. You might remember the point of the exercise with chocolates. Like if you're doing repeated sampling, you will get atypical results more often with a smaller sample size than with a larger sample size. Although it just shows how random is, right? When we actually tried it, we got 50-50 every time for both sample sizes, which kind of defeated the object of the demonstration somewhat. But never mind, you get the idea. If you did repeated samples of the same size, normally, and in the long run, you wouldn't get the same result every time. With the smaller sample size, you're going to get atypical results, extreme results, more often, just because the sample size is smaller. And we talked about ways samples can be biased that don't have to do with the size of the sample. We talked about self-selected samples or voluntary response samples where people choose themselves to get into the sample. Those kind of samples tend to be biased because people with stronger opinions are more likely to take part in them. In sort of common everyday reasoning and judgments about frequency and risk, when you're basing judgments about that on cases that come to mind that you can think of, again, that's an availability sample because certain kinds of cases are easier to remember, easier to bring to mind, more salient, because they're more vivid. I wanted to talk about one final way inference from a sample can go wrong, which is problems to do not so much with the sampling, the way the sample was selected or how big it is, but have to do with how the target property was measured. Suppose you were doing a sample of Australians and you wanted to find out, you're a social scientist, and you want to find out what the extent of racist attitudes is in Australia. So you send out a survey and you ask a simple question. You ask everyone, are you a racist? Right. And then you get the results back and publish them and go, amazing finding, only 0.5% of all Australians are racists or have racist attitudes. The problem with this, right, is just asking people a question like that isn't a very reliable way to find out the answer. Right? If you just ask people, are you a racist, most people are going to say no. Not all, but most. Right? Even if they do, in fact, have some racist attitudes. So that's an example of what, in the social science context, they'd call a self-reported measure. Those are quite often used in social science research because it's kind of easy, right, to just ask people and collect their opinion, right? If you really wanted to know, if you really want to do research on things like racism or, say, criminal behaviour or behaviour that's, say, cheating on exams or something like that, I want to know how many students cheat on exams, right? Even if I do an anonymous survey and ask students, have you ever cheated on an exam, the results probably won't be very reliable. Because people are going to lie a bit. People lie. And even when people don't lie in response to survey questions, they kind of, you know, they want to please the person asking the question. They want to, you know, and people have an idea what the expected answer might be, or what answer the researchers want. And they have a tendency to give that answer. And people just make stuff up. There's a famous case of one survey where they asked a number of questions, and at the end of this list of questions, it was about kind of local government or something like that. And at the end of the questionnaire, they asked this question. Many people now think that the General Administration Act of 1954 should be abolished. Do you agree? And something like 75% of people said, yes, I agree. There's no such thing as the General Administration Act of 1954. The researchers just made it up to see if people would answer a question that they couldn't possibly know anything about. And of course they did. Apart from that, there's this effect called framing, which is especially relevant when you're considering normative claims. And I was going to talk about it in the lecture on normative claims yesterday, but didn't get time to it. There's some stuff on this in those lecture slides if you're interested. In this context, apparently very subtle differences in the way you ask a question can make a big difference to the results. So here's some examples from real surveys. The first one's from the US. Are we spending too much on assistance to the poor? Only 13% of people answer yes to that question. Essentially the same question, are we spending too much on welfare? Now 44% of people say yes to that. And what about the last two? Do you support independence for Scotland? Yes, 51%. Do you support an independent Scotland separate from the United Kingdom? Suddenly the results go right down, 34%. It's hard to know what to make of this effect. So what does it mean? Are people in support of Scottish independence or not? It's like there's an assumption with these kind of surveys that people already have an opinion before you ask them. And then you ask them and they just report their opinion. But perhaps it's not quite so simple. Right? Perhaps people don't quite have an opinion before you ask them, and it's when you ask them, then they have an opinion, right? Like with the General Administration Act, right? And perhaps the way you ask them the question can change their opinion.